Okay, guys, get you situated on how we're going to do some things in this class. Sorry. Get you acclimated on video explanations. We'll do this with reviews, homework, and sometimes with some notes and in class at problems. So you got this note packet. What I need to talk to you about is the in-class, and we will address this in class, but I wanted to check off that you can access the videos, you know how to get to the problems, you can fill in the information, and then you can come to class with specific concerns that you have to a problem that you're doing. So I will be checking that you have these notes or these steps, or these hints that I'm going to give you on determining the quadrilateral. So to help you do this, kind of for each problem, ask yourself WTP, not WTF, WTP, okay? All right, WTP is basically asking what to prove, okay? What to prove. So if they ask, this is how can you use a formula to determine if a polygon in a coordinate plane is a rhombus? All right, so you got to know, what do I need to prove it's a rhombus? Well, a rhombus, you need to know that all sides are congruent, okay? If you have all sides that are congruent and it's a quadrilateral, then it's going to be a rhombus. So that means that you need to know, what do you need to prove? You need to prove the lengths are congruent. So on a problem like this, whenever it's dealing with lengths being congruent or determining the lengths, you use the distance formula. They ask what formula, you're going to use the distance formula. Or you can use Pythagorean theorem. We'll talk about that. That's a shortcut. I'm going to abbreviate that. Just get you some familiar with this. All right, so for each one of these, we're going to ask what to prove. So how can you use the formula to determine if a trapezoid on the coordinate plane is isosceles? Well, again, if it's isosceles, all right, we know it's already a trapezoid, but if it's isosceles, you have to have two congruent sides. So what is that? What do you need to know? You need to know if the lengths, are congruent. So again, what should you be using? What formula? Yep, distance formula. Good job. Now, if you're not sure, this is on your formula chart, so you don't have to memorize it, but just go ahead and get this in your notes so you know what it looks like. The distance formula is taking the square root of the difference of the x's, so that's x2 minus x1, parentheses squared, plus the difference of the y coordinates, y2 minus y1, parentheses squared, all right? Now, when you're doing these videos, you can pause, you can rewind, you can fast forward if you need to, but that's going to be up to you. You're going to still be held accountable for the information. So make sure you can access it, you can get the information down. If you need some assistance, you get that in class. All right, number 3, again, ask yourself, what do I need to prove? How can you use a formula to determine if a quadrilateral on the coordinate plane is a kite? Again, when I'm talking about if it's a kite, then you have to have two consecutive, write this down, sides congruent. So what formula are you going to use again? Yes, distance formula. All right, now we're going to go straight to knowing what to prove or how to pick the correct formula is just the first step. What we're going to get into is making sure you can apply it to an actual problem. All right, so determine whether JKL is scalene, isosceles, or equilateral. So again, what do we need to prove? We need to prove the lengths. So what are we going to use? We're going to use the distance formula. So we're going to do the distance formula for 2 vertices, 2 letters at a time. So let's do JK. So I'm going to take the square root. Remember, we have an x1, a y1, an x2, and a y2. So I'm going to put in my parentheses basically x2 minus x1. That's 1 minus a negative 2, parentheses squared, plus 6 minus 4, parentheses squared. And then we're going to simplify, do the order of operations, parentheses first. So I'm just going to rewrite that. That's not going to give me 3. 1 minus the negative 2 is actually going to be 1 plus 2, parentheses squared. And this is going to give me 2, parentheses squared. And then we do order of operations after parentheses is exponents. So that's going to be 9 plus 4. And then we're going to do addition. So that will give me the square root of 13. You can just get to the radical form because we can look to see if they have the same radical to determine the length. So we're going to do JK. Then we're going to do the same thing for the next combination. That would be KL. So I'm going to do difference of the x's, so 4 minus 1 parentheses squared plus 4 minus 6 parentheses squared. And I'm going to simplify. Order of operations says this will give me 3 parentheses squared plus negative 2, parentheses squared. But anytime you square a negative, it becomes a positive. Negative times a negative is a positive. So now we got 9 plus 4 again. What do we notice here? It is the same number. All right, so we now know we're at least looking at an isosceles, but we got to check the last one. And I think I ran out of little room, so I'm going to try to put this in the middle here. We did JK, we did KL. The last combination is JL. And that would be basically 4 minus the negative 2, parentheses squared, plus 4 minus 4. Sorry, I ran out of room. Basically, we have 6 parentheses squared plus 0 parentheses squared. Well, that's just going to give me square root of 36 is 6. So we have two numbers here that are the same. So that tells me I have two sides that are the same. So this would be isosceles. Okay. Now they want us to determine if the triangle is right. So what to prove? What do I need to prove to show right? For a right triangle. Well, if it's a right triangle, then you need to prove that you have a right angle. Or you can say, basically, you have, this is the symbol for perpendicular, upside down T. So what we need to prove, I'm just going to keep going. What I need to prove is really that I have opposite reciprocal, that's your abbreviation, slopes. So now you got to look at the slopes of each side. So I'm going to do the same thing, and we've kind of already done that, basically, because it's a change in y over change of x. So look at JK. Change in y is basically the difference in y. So basically we had 2 over 3. So look at the numbers inside the radical. For KL, the slope is a negative 2 over 3. Now you got to keep the signs. And then for JL, our numbers were 0 and 6, so 0 over 6. And if I look, none of these are opposite reciprocals, okay? Meaning they haven't been flipped, the fraction hasn't been flipped, or the sign, only the sign has been changed. It has to be a flip also. So no, we do not have a right triangle here. On here, this is just to see if you can determine which formula to use. Okay, read the question. Again, I have underlying key information. Trapezoid is important, okay? Our vertices, we need to know those. It says, which formula could help you find out if the trapezoid is isosceles? Is this an isosceles trapezoid? Explain why. So I just want to see, can you, on your own, determine the formula? And maybe try to do this one. So here's our in class. And then from there, we go into our homework, all right? So I'll do a separate video about that. So I just want you to access the videos and how you can do each one. And I'm going to check that you have this information in your packet and to verify that you can get into Edmodo and get this information down. All right, thanks.